purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 2, Building Conceptual Understanding of Place Value using Measurement and Data Reasoning. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 2. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety for the first time they appear in the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 2 AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. You will also see that we have provided the state's coding at the end of the IOAs so that if you are looking up resources on the Georgia DOE website, you are able to find those IOAs that is related to the GCPS IOA. Unit 2 focuses on using place value understanding to solve real-life mathematical problems, as well as solving problems involving customary measurements, metric measurements, and time. Students will also analyze graphical displays of data to answer relevant questions. Our first AKS, 5MMMAA1, has 2 IOAs. With IOA 1A, students will reason about the magnitude of numbers. They will work with the idea that in a multi-digit number, a digit in one place represents 10 times as much as it represents in the place to its right, up to 100 times greater, and 1/10 of what it represents in the place to its left, up to 1/1000th of its value. This standard extends previous understanding of the relationships of digits and whole numbers only to decimal fractions. Before considering the relationship of decimal fractions, students express their understanding of the magnitude of numbers in multi-digit whole numbers first. With IOA 1B, students use whole number exponents to denote powers of 10 up to 10 to the third power. Students explain what happens to the value of a digit as it shifts to the left or right and discover the decimal point remains between the ones and the 10th place as the digits shift. Students reason that the exponent in a power of 10 indicates how many places the digits are shifting. When we multiply by a positive power of 10, the digits shift to the left because the number is increasing by powers of 10. When we divide by a power of 10, the digits shift to the right because the number is decreasing by powers of 10. Students need to be provided with opportunities to explore this concept and come to this understanding. This should not be taught procedurally. Our next AKS, 5MAC7, has 4 IOAs. IOA 7A addresses the exploration of realistic problems involving different units of measurement, including distance, mass, weight, volume, and time. This IOA is clustered with both the metric and customary systems IOAs. IOA 7A and 7C are clustered as students are exploring realistic problems involving distance, mass, and volume that are practical and relevant to their everyday lives. This includes converting among units within the metric system and then applying these conversions to solve multi-step practical problems. IOA 7A is also clustered with 7D as students continue to explore realistic problems involving distance, mass, weight, and volume. However, 7D specifically focuses on converting among units within the customary measurement system. IOA 7B, that is also clustered with 7A, students ask questions and answer them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. In this unit, students will focus specifically on creating and analyzing line plots. Students will focus on other types of graphical displays in later units. And finally, you will find the new extension IOAs for AKS 5MAC7 to support the differentiated needs for each student. As you can see, the word extension is bolded and in parentheses to notify that these are extensions and specific to Gwinnett County. Please note you will not find resources from the state of Georgia for these IOAs. Pacing Guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Unit 2 has a suggested pacing guide, pacing of about 5 weeks. You will see on the pacing guide that there are 23 given days of instruction, which includes the Unit 2 assessment. Take note of the bullets on the right side of the pacing guide. These show the learning progression of the AKS and IOAs for each unit and the suggested manipulatives and tools needed. For Unit 2, you will need base 10 blocks and/or place value disk for IOAs 1A and 1B. IOAs 7A, 7C, and 7D, you will need a variety of measurement tools, which are listed on the left side of the pacing guide for each given day. Unit 2 opens up with 2 days of IOA 1A progressing from concrete to representational/abstract. This includes modeling and explaining the characteristics of place value as numbers ascend and descend in the base 10 place value system. Students will explain the value of the digits in relation to their placement using base 10 blocks and/or a place value disk with place value charts. There are 3 additional days clustering 1A with 1B progressing from concrete through abstract. During this part of the learning progression, students are introduced to exponents concretely and relate previous understanding of multiplying by powers of 10. Finally, students will use the relationship between place value positions to explain patterns when multiplying and dividing by powers of 10. It is important to emphasize that the decimal point does not move. It is the value of the digits that changes when a digit shifts to the left or the right. After progressing through 5 days of 1A and 1B, the focus will shift to 7A and 7C, the learning progression for metric conversions. Here, students will progress from concrete to representational to abstract to convert among units within the metric system only. This will include 2 days for each metric unit of measurement of length, distance, liquid volume, and mass. Initial introduction of metric conversion will incorporate a place value chart before transitioning to a 2-column table for the remainder of the progression. After metric conversions, before we shift to customary conversions, units of time will be addressed with students using clocks, number lines, and 2-column tables. Next, we have the customary measurement system. The learning progression is similar to metric conversions in that students will progress from concrete to representational to abstract to convert among units within the customary system using 2-column tables. This will include units of length, distance, liquid volume, and weight. For IOA 7B, the focus will be on interpreting data from a line plot in Unit 2. Other components of this IOA, including mean distribution, will be introduced in later units. On the right side of the pacing guide, you will notice a number of provided resources aligned to the bullets on the left side of the pacing guide. Throughout the pacing guide, you will notice different types of lessons: our traditional teacher-directed instruction and teacher task-based learning. For days where a task-based lesson is provided, you will see a blurb above that linked lesson. Additionally, you will see resources that have been pulled from Georgia Reveal curriculum resource for 5th grade. These resources are not directly linked and can be accessed via the GCPS portal. You will, however, see examples of lessons that have been adapted using Georgia Reveal components. Resources from the Georgia DOE have also been adapted and linked into the pacing guide. Some Georgia DOE resources have been directly linked. The Analyzing the Standards documents, or ATS, provide teachers with an overview of specific instructional strategies progressing from concrete to representational to abstract and suggested manipulatives. The ATS for each IOA is linked to the pacing guide at the beginning of each unit. These can also be found on the unit pages on eCom. The ATS has also been linked at the top of each lesson plan provided on the pacing guide. Learning progression for Unit 2 is not linear. There will be times where you may need to connect back to concrete models when exploring representational and abstract strategies. For this video, I will model using 2-column tables, a place value chart, and a Judy clock to model conversions. Let's start with our metric example first. Michael is building a swing set. He needs 2 pieces of rope that measure 100 centimeters each and 4 pieces of rope that measure 125 centimeters each. How many meters of rope does Michael need to purchase? So I know I need to think about what's going on in the situation. We know that Michael is building a swing set. To build the swing set, he needs lengths of rope. He needs 2 pieces of rope that equal 100 centimeters. And then he needs 4 pieces of rope that equal 125 centimeters. Now, what I don't know is how much rope he needs to buy in meters. I noticed that the lengths of the rope that's needed were given in centimeters, but we need to determine how many meters of rope Michael needs. So that means we will need to convert. But first, we need to determine how much total rope is needed in centimeters. He needs 2 ropes that are 100 centimeters each. So I know that 2 times 100 is 200 centimeters of rope. So then he needs 4 pieces of rope that are 125 centimeters each. In order to find this product, I'll use partial products. 125 times 4. 4 times 5 is 20. 4 times 20 is 80. And 4 times 1 is 400. Now we'll add up my partial products to get my total. 500. 4 pieces of rope at 125 centimeters each will give me a total of 500 centimeters of rope. I know I need to add these together to determine how much rope he needs in centimeters. 200 centimeters plus 500 centimeters will give me 700 centimeters. Now, I know I'm not finished because I need to determine how much rope Michael needs in meters. So I'm going to make a 2-column table because I was given some information. 1 meter is equal to 100 centimeters. I'm going to start with my centimeters here, and I'm going to convert to my meters. Now, I know that 100 centimeters is equal to 1 meter. So 200 centimeters will be 2 meters. 300 centimeters is 3 meters. 400 centimeters is 4 meters. Now, I could continue going on to 700, but I noticed something. I noticed that the value of my centimeters is 100 times less than the value of my meters, or 100. I want to use my knowledge of powers of 10 to determine how many meters are in 700. So I know Michael needs 700 centimeters. And I know that each time, and I need to make this number 100 times less, or 1/100th of this value to get my number of meters. I know each time I shift to the right, the digit will become 10 times less. I need this value to be 100 times less. So that I need to shift my 7 2 times to the right. So if I shift my 7 1 time to the right, or take 1/10 of the value of 700, I have 70. If I take another 10th of 70, because 10 times 10 is 100, I have a value of 7. So 7 is 100 times less than 700. This means that Michael needs 7 meters of rope. Now let's practice converting units of time. Here's our situation. Jane spent 1 3/4 hours practicing playing the piano. Her friend practiced playing the piano for 97 minutes. Who practiced playing the piano for a longer amount of time? And I've been given the information that 1 hour is equivalent to 60 minutes. I'm going to think about what's going on in the situation. I know that there are 2 friends that are playing the piano. I also know that they play the piano for a different amount of time. So I'm going to record the amount of time each friend spent playing the piano. Jane practiced the piano for 1 3/4 hours. Jane's friend practiced the piano for 97 minutes. I can see that the amounts of times were given in different units. Jane practiced the piano in hours, and Jane's friend's time is given in minutes. I know I will need to convert in order to determine who played the piano for a longer amount of time. I'll start with Jane's friend first. I know that I was given the information that 1 hour is equal to 60 minutes. I can see that Jane's friend practiced playing the piano for more than an hour. So I'll subtract 60 minutes to show that. 97 minus 60 gives me 37 minutes. So I know that Jane's friend practiced playing the piano for 1 hour and 37 minutes. Now I need to figure out how long Jane played the piano. I can see that Jane played for at least an hour, but she did not practice for 2 hours. So she practiced for an hour and some minutes. I have to figure out how many minutes are 3/4 of an hour. I'll use my clock to help me determine that. Now, I can see that an hour is 60 minutes. Half an hour is 30 minutes. I know that because half of 60 is 30. So when my minute hand reaches the 6, half of the hour has passed by. I'll show half an hour using my marker. All right, I know I don't need half an hour, I need 3/4 an hour. So I know I can partition my hour into fourths by drawing a line from 3 to 9. Now I have fourths. When the minute hand has gone from the 12 to 3, 15 minutes have passed by, and that's 1/4 an hour. When the hand moves from the 3 to the 6, that's 2/4 hour or half an hour, and that's 30 minutes. When the hand moves from the 6 to the 9, I know that's 3/4 an hour, and that's 45 minutes. So Jane practiced for an hour and 45 minutes. Because 3/4 of an hour is 45 minutes. Now, I know I'm not finished because our question asks us to determine who played for a longer amount of time. 1 hour and 45 minutes is greater than 1 hour and 37 minutes. So Jane played the piano for a longer amount of time. Let's move on to our customary example. Tyler's school is having a rocket contest. To be in the contest, each rocket must weigh 4 pounds or less. Without any paint, Tyler's rocket weighs 62 ounces. If Tyler wants to paint his rocket, what is the weight of the most paint he can use? 1 pound is equal to 16 ounces. Again, I need to make sense of what's going on in the situation. I know that Tyler's school is having a rocket contest. And I know in order to be in that contest, the maximum weight of each rocket must weigh 4 pounds or less. I also know the weight of Tyler's rocket. Tyler's rocket is 62 ounces. Now, what I don't know is what is the weight of the most paint that he could use in order to compete in the contest? Now, I noticed that the maximum weight in order to be able to compete in the contest is given to us in pounds. The weight of Tyler's rocket is given to us in ounces. So I know I will need to convert. I will convert pounds to ounces using a 2-column table. Converting pounds to ounces. I know that 1 pound is 16 ounces. If 1 pound is 16 ounces, then 2 pounds must be 32 ounces because 16 plus 16 is 32, or 2 times 16 is 32. 3 pounds then must be 48 because 3 times 16 is 48 ounces. 4 pounds would be 64 because 4 times 16 is 64. Now, I know that the maximum weight is 4 pounds, so I can stop there. 4 pounds is equal to 64 ounces. In order to determine how much paint Tyler can use in order to compete, I would need to find the difference in the maximum amount of ounces and Tyler's weight of his rocket. So the maximum weight is 64 ounces. Tyler's weight is 62 ounces. In order to find the difference, I will need to subtract. There is a difference of 2 ounces. So this must mean in order for Tyler to compete in the contest, he can use 2 ounces of paint.